Welcome to our machine learning series. In previous video, we covered a basic introduction to machine learning. Machine learning can be categorized into supervised learning, unsupervised learning, semi-supervised learning, and so on. Today, we will learn about supervised learning. Let's get started. Supervised learning is a type of machine learning where the algorithm learns from labeled examples with the help of a supervisor, hence the term supervised. It is like teaching a computer by giving it examples and telling it what those examples represent. It uses labeled datasets to train algorithms to classify data or predict outcomes accurately. And the accuracy of the predictions made by the model depends on how well it was trained. Let's use an example to understand supervised learning. Imagine we have a collection of images of cats and dogs, and each image is labeled as either a cat or a dog, as you can see. We want to teach a machine learning model to recognize the difference between these two animals. During the training process, the model carefully examines the labeled images to find common features that distinguish cats from dogs. It looks at things like shape of the ear, color patterns, and face structure. By studying many labeled images over time, the model gradually learns which patterns or combination of features are associated with each animal. So here, in the training process, the supervised model will learn how to categorize images based on the features present in the image. Now, how would the training be utilized? Once the training is finished, we give the trained model new unseen images and ask it to categorize whether each image contains a cat or a dog. The model uses the patterns it learned during training to make its predictions. It looks for familiar features in the new images and assigns the appropriate label based on what it recognizes. As you can see, it here categorizes the first image as dog and the second image as cat. Independent and dependent variables. Independent variable refers to the input features, such as image of cats and dogs, while the independent variable or target variable is the output data, like labeling the image as cat or dog. Dependent variable is called so because its value depend on the independent variables. Let's take an example. Suppose you have the house rent data of a locality which includes number of rooms, size of house, balcony, rent. Now, number of rooms, size of house, and balcony are independent variables or input features because they are deciding factor for the rent and not vice versa. While the rent of a house is dependent on the other features. Thus, we call rent as a dependent variable, and the ML model will predict this dependent variable using the other features present, like number of rooms, size of house, and balcony. Supervised learning is used here as we have a label, rent, which we need to predict based on the input features. Now I hope you have a clear understanding of independent and dependent variables. Notice that in the example of cats and dogs, we classified images, and in the previous example, we predicted values. Regression is primarily used to predict or estimate the value of the dependent variable based on the values of independent variables, like we predicted the value of house rent based on previous data. While classification involves predicting the class or category of a given input based on a set of labeled examples, like we classified the images of cats and dogs. Regression and classification are the two main applications of supervised learning. These are some popular supervised learning algorithms. We will cover each of them in the future videos. For now, you can pause the video and read about them in brief if you want. Applications of supervised learning. Image classification. As we discussed earlier, supervised learning can be used to classify images. It enables applications like object recognition, facial recognition, and medical image analysis. For instance, it can help identify diseases from medical scans or automatically tag people in photos or on social media. Supervised learning can be applied to filter out spam emails by training a model on a labeled dataset of spam and non-spam emails. Sentiment analysis. Supervised learning is used in sentiment analysis to determine the sentiment or opinion expressed in text. These texts can be customer feedback or social media posts. Fraud detection. Supervised learning can help detect fraudulent activities in various domains. By training a model on labeled data that includes fraudulent and non-fraudulent transactions, the model can learn to identify patterns indicative of fraud, such as unusual spending patterns or suspicious behavior, in order to flag potential fraudulent activities. These are just a few examples of many applications of supervised learning. In general, supervised learning is applicable in any scenario where label data is available, and the goal is to make predictions, classification, or understand pattern in new unseen data. In this video, we covered the basics of supervised learning, its meaning, applications, independent and dependent variables, and an overview of algorithms that come under supervised learning. In the future videos, we will learn in depth about each algorithm, ML workflow, and data processing. So stay tuned, and thank you for watching.